Hello students, welcome to the physics class. Today we are going to study a very important chapter of class 11 physics, and the name of the chapter is motion in a straight line. Sometimes we call this as motion in one dimensions, and the reason is, let me explain you. Suppose a car is moving in x-axis, it can move in a straight line. Suppose a car move in y-axis, it is also can move in a straight line. A car moving in z-axis, it can also move in a straight line. So in either of the dimension, if it is moving, it will be called as motion in one dimensions. It can be x-axis, y-axis or z-axis. So a car speeding in a highway, it's a motion in one dimension or motion in a straight line. It can either move in positive x-axis or negative x-axis. You can take y and z as well. A train moving in a railway track is a motion in a straight line or motion in 1D. Now what if a book is resting on a table? Is it a motion? No. The reason is the book is not changing its position with respect to time. That means there is no change in position with the passage of time, although there is a force acting on the body which is given by F equals to mg. The reason is acceleration due to gravity. All the type of straight motion or motion in a straight line will be called as rectilinear motion. This is all about the introduction part of the chapter. Now we will move it to the next topic. So students, this is the first topic of the chapter called position, path length and displacement. So let us understand one by one. So before that, we have to understand what is kinematics. Kinematics is a branch of mechanics which deals with the motion, but it does not talk about the cause of motion. A body is moving from point A to B. It will not give us the cause of the motion, but it will describe the motion only. That is kinematics. Now, kinematics can be studied in the form of rest and motion. So let us understand what is rest. Any object which is not changing its position with respect to the time, as I told you in the introduction part itself, that is known as rest. A man sitting on a chair is a rest. I am standing. Right now I am not changing my position. This is also rest. So next is motion. What is motion? Any object changing its position with respect to the time is called as motion. You can see an example here that a car is moving in a highway. So there is a question by every scientist. There is old scientists, Albert Einstein, Galileo Galilei, everybody has questioned about one thing, Newton, that when a body is at rest, is it at rest completely or there is something else in it? Yes. So we come to the conclusion that rest and motion are relative terms. What you see at rest might not be at rest for me. As for example, you are looking at a car moving on a highway. Now for you, the car is moving. Now imagine me sitting in the car looking outside. If you are standing outside, I will find that you are also moving backwards. That means you are not in rest with respect to me. You are in motion. That's why we say rest and motion are relative terms. It depends on a very important word I am going to speak now is frame of reference. What is frame of reference? It is called as if a person is observing a particular object from its own place. The place from where the motion is observed or measured is known as frame of reference. A car moving in a highway, I will take the same example. You sitting in the car looking outside and you being outside looking at the car are two different types of motion. Motion has been divided into various types. The first thing we learn is displacement and distance or path length or displacement. So let us understand what is distance or path length. Suppose a body wants to move from point A to point B. It can take the path C or it can take the path D. What I mean to say is it can move through the path C, it can move through the path D, as well as it can take the shortest path directly from point A to point B. So these are called as path length. ACB, AB, ADB, all these are called as path length. In short, we say this one as distance. So distance is a path length covered by a body from one point to another point. What is the unit of distance? The unit of distance is meter. Distance is a scalar quantity. Scalar quantity means it has only magnitude but there is no direction. Reaching at point B was more important. The path was not important. It can take any path it wants to. So there is no specific direction, so it is a scalar quantity. Distance of a body can never be negative. It is either 0 or positive. So this is all about distance. You have seen why distance can never be taken as negative, because it is a scalar quantity and we only take the positive side or else 0. The magnitude is considered. Now we will start a topic called as displacement. What is displacement? The shortest distance covered by the body from its initial position to its final position. We can also say that the change in position is the measurement of displacement. Suppose a body is moving from point P1 to P2. That body can be car or anything. Now how we are going to find out the displacement? That is change in position, P2 minus P1. In short, we can say x2 minus x1. x2 is the distance covered from the origin till P2 and x1 is the distance covered from origin till P1. What is the unit of displacement? The unit of displacement is meter. Displacement is a vector quantity. That means it can be either positive, negative or 0 as well. When I say negative, when I say minus 2 meter, it doesn't mean that the magnitude is minus. It means the direction of the body is opposite with respect to the frame of reference. Negatives tell us the direction. So you will be observing some graph which will help you to understand the concept of displacement and time. So let me show you the graph based on displacement and time. On the x-axis you take time and on the y-axis you take displacement. Number A, for a stationary object, suppose a body is at rest at a displacement of 40 meter or at a distance of 40 meter. How the graph will be? The graph will be shown like this. It will be a straight line parallel to the x-axis. With the passage of time, the body is still at 40 centimeter or meter. Second part, when the body is in uniform motion, means there is a displacement with time. So again, if you put on x-axis time, on in y-axis displacement, the graph which we will get is a linear graph. That linear graph shows that the change of displacement is done in a regular interval of time. Means 2 meter in 2 seconds, then another 2 meter in another 2 seconds. Number C, what is a non-uniform motion? The graph can be drawn for that also. In the x-axis, you take time and in the y-axis, you take displacement. The curve which you are going to get in the graph will not be a regular curve because the position is not constant or in regular interval of time the displacement is changing. There will be irregular curve showing in the graph. So my dear students, this is very important to know what is the difference between distance and displacement. What is distance and what is displacement? Why distance is a scalar quantity? Why displacement is a vector quantity? All those things should be known. So this is all about distance and displacement. Now we are going to move to the next topic. Now we are going to start a topic called as average speed and average velocity. So before learning average speed, we need to know what is speed. So my dear students, speed is equal to distance by time. Distance covered in a particular time. So we can now study average speed. Average speed is equal to total distance covered divided by the total time taken by any body moving in any of the direction. It can be x, y or z. Suppose a car moves from point O to A with a speed of 50 km per hour and then again from point A to point B with a speed of 70 km per hour. Now we need to calculate the average speed. How you are going to do? We will apply the formula again. Total distance covered divided by total time taken. So what is the total distance? 50 plus 70 divided by what is the total time taken? 1 plus 1, that is 2 hours. So that is how you can calculate the average speed. The unit of speed is meter per second. It is a scalar quantity, which goes to say that it can only measure magnitude, not the direction. Speed does not have a specific direction like distance. It can be 0 and positive. For a scalar quantity, it can only be 0 and positive. We have already discussed about it. So students, you have learned what is speed, what is the unit of speed, and why it is a scalar quantity. These are the things required to do many numericals, so keep that in mind. So now, we are going to start a topic called as average velocity. To learn average velocity, we need to know what is velocity. Velocity is the rate of change of displacement. Average velocity can be written as total displacement divided by total time taken. Again, suppose a body starts from point 1, which is kept at some displacement away. Now, it reaches point 2. How you are going to find out the average velocity? That means total displacement covered by total time taken. Now, what will be the displacement? x2 minus x1, and the time taken will be t2 minus of t1. So, this is the procedure where you can find out the average velocity, and you can get the answer in a click. What is the unit of velocity again? It is same as speed. The unit is meter per second. It is a vector quantity, which is very important to know. That means it will have magnitude as well as direction, which says that it can be negative, 0 as well as positive. Right? You can take many examples of vector quantities, velocity, then displacement, force, all those are vector quantities. So, my dear, vector is divided only on magnitude and what? Directions. So, velocity is one of them. So, you have learned completely about average velocity. You can find out the numericals based on average velocity if you use this formula. Okay, now you are going to study the graphical representation of velocity. You will put a graph between displacement and time, that is xt graph, and find out velocity at different positions. Now we are going to do the graphical representation of velocity. We will plot a graph between time and displacement. So, let us understand the first part. When the body is having positive velocity, what does it mean? It can be understood graphically. So, at x-axis if we take time, and at y-axis if you take displacement, which is given by x, then the positive velocity will be a linear graph. That means the body will have positive displacement with the passage of time. Next, if you want to calculate the negative velocity, how you are going to do? Again, graphically it can be proved. In the x direction or in the x-axis you put time, and in the y-axis you put displacement. You will see that the displacement keeps on decreasing with the passage of time. That is known as negative velocity or graphical explanation of negative velocity. Now, how about this one? When the body is at rest? We have already come up through those type of graphs where the body is at rest. Ultimately, what it will come? The body is at rest means it is not changing its position with respect to time. If it does not change its displacement with the passage of time, that means the velocity is going to be 0. So, the body is at rest and the graph is as usual the same graph. At position wherever the graph starts, wherever the object is at, the graph you will see that the line is parallel to the x-axis or it is parallel to the time. Note a very important point. If you compare speed and velocity, speed is always greater than a velocity. Now, the question is why, sir? See, speed is equal to distance by time, and we have already studied that in distance the body can take any path, it can take the longer path also. But in velocity we have to take displacement by time. When you talk about displacement, it is only the shortest path, it has a specific direction. So, distance is always bigger than displacement, hence speed is always bigger than velocity, right. So, the ultimate final graph which we get from displacement and time is that the slope of the graph, slope of a uniform velocity graph will give me the velocity. If you put a graph, in x-axis you put time, in y-axis you put again displacement, and the graph is a linear graph. You take the angle theta, you will see that tan theta is equal to perpendicular by base, isn't it? So, if you take perpendicular by base, you are going to get displacement by time from the graph, which is nothing but your velocity. So, this is how you can calculate velocity in the graph. For different format, if the body is in uniform motion or non-uniform motion, or body is at rest, what will be the velocity can be explained graphically. Now we are going to start a very important topic of the chapter, that is known as instantaneous speed and instantaneous velocity. Now that we have already covered average speed and average velocity, what if you wanted to find out speed or velocity at a particular instant of time? For that we are going to do this topic. Now, what is instantaneous speed? Let us understand this one first. Suppose we have 3 points, point A, point B and point C. The car moves from point A to B and then B to C, right. Now, you want to find out the speed at point C or B or A. That measurement of the speed is known as instantaneous speed. In definition, we can write down the speed of an object or body at any instant of time is known as instantaneous speed. There is a mathematical expression also, which is exactly like the velocity one. So, I will be discussing the mathematical expression in the velocity. So, what is instantaneous velocity? They both are related. So, the graphical representation will help you to understand what is instantaneous velocity. So, if I put a graph between x-axis and y-axis, in the x-axis we have time again, and in the y-axis we have displacement. Suppose a body covers a displacement of point P to point Q, and the body has covered P Q dash Q, this is its path. Now, how you are going to find out its instantaneous velocity? Again, we have to take the concept of slope. Suppose a student wants to know at point Q dash what will be its instantaneous velocity. Simply you are going to do the slope. What is slope? That is tan theta, delta x by delta t. If you want to go to more lower terms, because instantaneous speed and velocity is for a very small amount of time. So, we are going to do dx by dt. Dx is the smallest displacement and dt is the smallest time. At that particular time, what was its velocity and time? How? Dx by dt. So, this is how you can calculate average velocity and instantaneous speed and instantaneous velocity. See, the representation of velocity is same for speed also. If you need to find out the speed, you again going to do dx by dt. You will take the smallest distance and the smallest time during that instant. Yeah. So, what you have learned from this topic? We have learned what is instantaneous velocity, what is instantaneous speed, and the units are going to be same. Afterwards, they are what? They are speed and velocity, meter per second, right. On the instantaneous velocity will have a specific direction, it is a vector quantity, and instantaneous speed will be a scalar quantity, only the magnitude will be counted, not the directions. So, this is all about this topic.